All right, guys, so today we're going to be talking about how to convert these annual costs and the salvage costs into present worth terms. So we're given a problem here where our initial costs are given, our annual costs are per year over an 8-year period, and after that time period, we have a salvage value where we're selling it back. We're given a discount rate of 12%, and we'll be discussing why we need a discount rate in a moment. In order to complete a present worth problem, we need to understand a cash flow diagram and how these two equations work and what they actually do for us. So cash flow diagram is just a graphical representation of the data that we were given, where we have an initial cost, the annual cost over an 8-year period as specified by the problem, and our salvage value. What we're trying to do is get these values in terms of today. So we need a way to move these values over into today's money. And the equations provided before allow us to do that. These are the equations that we're discussing, where P is the present value amount, F and A are the annual cost, and I is the discount rate. And we need a discount rate because those values are worth less to us today. And so we need to discount it back so that we have it in terms of today. And N is just the compounding period, the number, in this case, years. There are two methods to solving this. The first method is using this equation here. And we're just going to plug in our values. This is the annual cost. And the only thing that changes would be the compounding period. And we need to do this, add it up. So work out this calculation and add it up, and that's what I've done here. For this example, this is our total present value cost, and it's negative, so we're paying that amount. But method 2 is faster. It allows us, this formula here allows us to take all of those 8 values and package it together. So instead of having to do those calculations individually, we use this equation and it does it for us, and we get the same term. So I've gone ahead and done that for sections B, C, and D using the second method, but we also need that first method because there's only one value here that's being compounded and brought back. These are our values that we're obtaining. I've gone ahead and included that just as a table here, and the problem that we're given requires us to find the two most cost effective, that's B and D. These values are least expensive to us, we're spending less, and to find the difference between these values would be about 170.